Welcome back. The point of this video for the Year 12 Math B is to clarify, work through the issue of how we handle some of the annuities. And the first annuity example we're going to look at now is a loan. Okay, and the headline is when we are repaying a loan, it's going to be a present value calculation. I'll elaborate that on the screens to come. Righto, we're going to be considering a loan. This is actually the example that we did in class. There's a $30,000 amount over a period of 10 years, 12.99% per annum. And our goal, this is the thing that we're really trying to achieve here, is that there's going to be 10 equal repayments. 10 equal payments, okay, over the life of the loan. So that's 1, 2, 3, 4, etc., across the timeline there. Now, probably the thing that needs to be worked through the most on these ones is how do we handle it? Is it using the present value formula or the future value formula? They're subtly different, and one of them gives you a much bigger number than the other. Okay, this is what we need to remember. You are taking out a loan for $30,000, and it's going to be payable at the beginning of the loan. Okay, $30,000 payable beginning of the loan. That's now. That's in the present. We want the $30,000 now, so it's being paid to us in the present. So lock it in. It's going to be a present value calculation. As mentioned then in the previous slide, all loan scenarios where there's a repayment are going to be handled as a present value task. Okay, so the formula really does become about the present value, and this guy here, this thing here, is a present value factor. We're going to find that using the formula detailed below. Okay, you don't need to remember that. But effectively, we're going to find a present value factor and a series of payments. Okay, so we're ultimately going to be putting the 30,000 over here, and then determine a value for this, and this guy here, the periodic payment, that's what we don't know. That's what we're going to be solving for. This is how we rearrange it. Now, the process of calculating the present value factor is relatively straightforward, and we'll get a 5.43 at the bottom of that. What's intriguing with these, and it's where the textbook just completely oversimplifies it, is that if you're repaying a loan and you have to decide whether or not you're going to be making your first payment on day one, or in this case, a year later, we need to think about the impact of that. If you're paying off installments on a loan, every time you make an installment, you pay off some of the loan, and you reduce the interest and you get closer to the goal. If you defer your first payment until the end of the first year, then you're going to be, from the perspective of paying off a loan, you're going to actually make larger payments. Because had you paid your first amount of money on day one, then you would have paid down a big chunk of money. You wouldn't be paying any interest on it, and the whole thing would go quicker. So the A value, okay, the present value factor, we need to consider whether or not we're looking at one option or another. And in this case here, okay, we are going to be adjusting it up by 1 plus I. We're going to be doing that multiplication that's routinely discussed in the textbook. This here, okay? It means we end up with a 6.13 present value factor. And if we ask ourselves, back up to the section of the screen where we're looking at calculating our repayments, just change to green. So we're up here and we're repaying. If you have a bigger value there, excuse me, you're going to get a different payment. In any case, we get 6.136, and I'll move on. Based on our 6.136 that we get there, we divide that into 30,000 and we get $4,889 a year. What that would actually mean is if you were to look at your repayments over the period of the loan, you're making 10 of these, almost 49,000 would be what you pay off on a $30,000 loan. I'm going to go on now to do one more example of this. I'll continue to clarify it. We've got here another example. This is a home loan, more of a realistic scenario in terms of a long-term commitment. Home loans for $270,000 over 30 years. We're going to work on it as an annual instalment, paying it back, and typical interest rate of around 7% or 7%. As previously mentioned, loans of any size where you're repaying them are to be worked out using the present value method. Okay, that's because the money's being handed over at the beginning of this process. In the present, we're receiving $270,000 from the bank. Here it is. Now, in this instance, we're going to be making the first repayment at the end of the first year. So if we go back to previous considerations, that means that the loan is going to be slightly more expensive because you're deferring your first payment until the end of the first year. That means essentially everything's going to cost you just one little bit more. Okay, now present value formula down here, we get our A value of 12.409. Now, in this instance, the adjustment is not required. The adjustment is not required. Okay, that's what I mentioned there. We're going for the more expensive option of loans where the payments are deferred. So we arrive at a payment calculation here using a similar method to previous, where we have an annual payment of almost $22,000. In that instance there, we get ourselves a $650,000 total repayment bill on a loan that was $270,000. That's why these things take so long to pay off, because you end up paying 2 or 3 times the value of your house or your loan off over the time period that you've got it. But 20, 30, 40-year loans accumulate a lot of interest. Alright guys, hopefully clarifying. Headline issue is that when we're talking about loans, we use present value method. And that's because when you take out a loan, you want the money on day one in the present. Hopefully been of some assistance to you. Stay tuned for the next thrilling installment of maths.